Welcome to a lecture on lists. Finally, we can now program Python the way it was meant to be programmed because lists are super important in Python. Not having lists until now is just weird, but that's the way that the textbook teaches it, so that's the way we teach it. So these are the objectives for this lecture. We're going to describe a list as a sequence, figure out what those things mean, describe how to slice and copy lists, describe how to find elements inside a list, recall useful methods and functions to use with lists, and how to process one-dimensional and two-dimensional lists. We've already seen the one-dimensional thing when we were doing for loops, so now we can really kind of dive into that. So here's the problem. Let's say you have, the names of 10 people, 10 students, 10 people come into your party, whatever, 10 people. Variables can only hold one value at a time. So if you wanted to have the names of 10 people without lists, you need 10 variables. Name 1, name 2, name 3, name 4. And then you have to figure out how to work with each of those and lots of if statements. It's a problem, let me tell you, because lists solve this in a really elegant way. So up until now, we know that variables only hold one value. And let me tell you, it's still true. A variable only holds one value. And if our variable is a list, it holds one list. And that list then can have many things inside it. So over here on this side right here, this is a packing list I put in a suitcase for a trip I took a couple of months ago. And you can see there is one list in here. This is it. This is one list. But on that list, there are many things. This is all the crap that was inside my suitcase in case it got lost or whatever. And here's my name, so they know how to send it back to me. But this is one list. You see that? There's one list there. It's one piece of paper, and it's got multiple items on it. So that's how we have to think of lists. Variables that have lists do not have multiple values. Variables have a single value, and that single value is a list, and then that list has multiple things inside it. So a list is a sequence, which means that things are in order. If we look at the list over here on the right, we can see that the first thing on the list is this keyboard, and the last thing on this list is some Birkenstocks, and in between, there is an order to these things here. Even though they're not numbered, we can look at them and say, oh, there is an order. It goes from the first element to the last element, just like that. That's what a sequence means, and a list is a sequence. It has a first element, it has a last element, if it's not empty. You can have an empty list. Imagine my piece of paper here, but instead of having stuff on it, I just had my name, and I didn't put anything in my suitcase, and it's just like this. Now the list is empty. What's that mean? It means it has no elements in it, but it's still a list. It's just waiting for elements. And I cannot stress it enough. Items inside a list are called elements. So how do we make lists in Python? Well, we use almost always the square brackets. Square brackets. We've already seen this in our for loop stuff. We use the square brackets. This one here is an empty list, and the one below it is a list that has two things in it, nor and ASA, and this is the first element, and this is the last element. Here I've got a list that has multiple values in it, and they're all different data types. Here's an integer, here's a string, here's a Boolean. This is the first item in the list, this is the last item in the list, this is the second item, this is the third item, and they're in order. It's not like, it's not like false is going to jump to the front of the queue really quick or anything like that. I mean, it's not a jerk or anything. So a list keeps things in order: first, second, third, fourth, etc., etc. Finally, lists are always finite. So you can't make an infinite list. You can have infinite things in Python, but they're not lists. The reason why is, how do you type an infinite number of things inside these square brackets? You can't. So that's it. That's just, lists are finite. So once we have a list, how do we get stuff out of a list? How do we do something with it? We use these square brackets right here with the variable name and then a number. And that number is the index. That's the index of the item in the list that we want to get out. So if we want a specific one, we use that number. If we're using a for loop, it just pulls them out for us. What trips up a lot of beginning Python and really just almost every programmer for almost every language, there are languages out there that are different, but in this case, Python is a lot like almost every other programming language, and the first element has an index of 0. So this is a 3-item list, and its indexes go from 0 to 1 to 2. So the last element is always going to have an index, a positive index that is one less than the length of that list. So in this case, print names index 1. Python says, okay, here's my list. I'm going to go to index 1 and get that value, ASA. And then that's what gets printed out here. What's unique about Python in many ways, although there are a few other languages that support it, but most don't, is the fact that you can have negative indexes. Really kind of cool. And negative indexes start at the end of the list and go backwards. And the first one is -1. Sorry, the last element is -1. The second to last element is -2. The third to last element is -3, and so on. So if you want to access things in a list backwards, you can use negative numbers for your index. So in this case, names -1. Python says, okay, I'm going to go to the end of the list. I want -1, so that's going to be the first element at the end of the list, or the last element, and that's the thing that ends up getting printed here. So we already saw this in our for loop section. So this is how we can loop over lists. Every loop of a list is a definite loop because lists are finite, which means that it will definitely end. This loop will definitely end. And so in this case, it prints out the names Nor, and then Asa, and then Carl. So it prints those out in order. Go back and watch the lecture on for loops if you want more details about how that works. If we want a list that is like a multiple of a single list, we can use what's known as the repetition operator. I'm going to tell you, we don't use this all that much. It's not a thing, but it's in the book. Might be on the quiz. So if you have a list that has the number 0 in it and you multiply that list by 5, it creates a new list with that value in it 5 times, just like that. 0, 0, 0, 0, 0. So 5 zeros is going to be a new list that has 5 zeros in it. Now, if you take a list like 1, 2 and you multiply it by a thing, it just takes those values and repeats it that number of times. So it's going to take 1 and 2 and it's going to create a new list that has that 3 times. So 1, 2, 1, 2, 1, 2. And so dumb thing is 1, 2, 1, 2, 1, 2. And like I said, we don't use this very much in our programming, but it's, I don't know, great to know. I don't know. It's a thing. So now we're going to talk more about how we work with lists, because we can do more than just get values out and loop over them. So we can change specific values in a list if we want to, which is good because sometimes we need to update something inside the list. We need to replace a value that's already in there. So what we do is we use the same sort of thing with the variable name and the square brackets and then the index. And remember, our indexes are 0, 1, 2. That starts at 0. Don't forget that. And so with that in mind, what we do is we end up having this, we specify which slot, which element, name 0. So that's the first element. And we set that equal to Curtis. Hey, that's me. And then we can also still use our negative indexes to do that. So names -1, let's remember that, -1, -2, -3. Names -1, we can set that to Zubair. And so we originally start with Nor, Asa, and Carl. Curtis goes into the 0th here and replaces that. Zubair goes into the last one here and replaces that. And now we have Curtis, Asa, and Zubair. So we can use indexes to update specific elements in the list that we're interested in changing. We can also create a new list by taking 2 lists and adding them together, otherwise known as concatenating. So concatenating just means putting the 2 things together. And in order, that's the important part. Concatenation means in order as well. So if we have trees There's a list of trees here that have oak and elm in it, and we have a list of flowers that just has the poppy flower. If we add those together, trees plus flowers, to get a new list named plants, we can see that plants contains what was first in trees here, oak and elm, and then poppy on the end, right here, poppy. So plants is a brand new list. It doesn't really have anything to do with this. What Python does is it says, I'm going to create a new list, and it's going to have, this has 2 elements in it, this has 1 element in it, so I'm going to create a new list. It's going to have 3 elements in it, like this, 3 elements, and then I'm going to go ahead and put those values from the original lists into it. So it's a brand new list. That's really important to understand, because there's a difference between changing a list and creating a new list based on old lists. That's it. So this is probably the most important thing to know about how to work with lists, and that's the append method, which adds new values to the end of lists. End of lists, right there, end of lists. So if we start off with a list, Nor, Asa, and Carl, and we call names.append, it changes the original list, and it takes this value and it puts it here at the end. So we can see now, after we append something and we print it, we get Nor, Asa, Carl, and Super. So append changes the list that you're working with by adding something to the end. This, like I said, this is when I do Python programming and I'm working with lists, there are 2 things I primarily do with them. I loop over them and I append to them. So this is really like, this is like, bread and butter, right? This is like staples, man. This is just like building blocks for our programs. Python has a built-in function called len, which stands for length. And the len function allows us to find out how long a list is. That's all it is. So we type len, and then we give it the name of the variable that has the list in it that we're interested in, and we can get the length. So in this case here, name starts off with 0 elements in it. 0 elements inside that. It's an empty list. And then we say while that length is less than 5. So what's that going to do? It's going to ask somebody for their name and then append. It's going to put it at the end. When you put it at the end of an empty list, it just plops it inside there. And then that list has grown. The length of it has grown by 1. And so it's going to come back up here and check, hey, are you still less than 5? The answer is yes. So it's going to run this again and get another name. And that's going to be like, are you still less than 5? There's 2 in there. And it's going to be, yeah, I'm going to go. So this is a way that we can go about getting, for example, like I want to have 5 names for somebody. So while the length of this list is less than 5, keep asking for names. That's one use of the length function. Another couple functions that we can use are the max and min functions. To be honest with you, these generally we don't use these very much, not like when we're just doing normal programming, but every once in a while they come in really handy when you want to find the biggest and the smallest value. The things inside the list need to be comparable. That means they usually need to be the same data type. But you can have, for example, like integers and floats in the same one and it'll still work. If you put an integer and a string inside the list and then you ask for the max or the min, it's going to blow up. It's going to be like, I don't know how to compare the number 1 and the name Curtis. Those things do not compute for me. So generally we need to make sure that our lists, if we want to use max and min, our lists need to have the same data types, or at least comparable data types that can be compared with each other as elements in our list. Let's say you have a list and you want to get rid of one of them, one of the elements inside it. So in this case here, you use what's known as the delete statement, or del. I don't know. Guido, who invented this language, really loved like 3-letter things. So, it's like def and del. I mean, come on, Guido, I can spell out delete. It's only 3 more characters. Anyway, so when I say I want to delete element at index 1, and remember 0, 1, 2, 3, 4, it's going to go to this list, go to that element at index 1 and be like, you're gone. it doesn't replace it with a value. There's no none value. It doesn't go in there and put in like some sort of default value. Literally, the list is now one element shorter. It's now 4 elements long as opposed to 5. It ripped it out of there is what I'm saying. Another thing that we do quite often, for real, is sorting things. Computer scientists love to sort things. So in this case here, we have a list, 1, 10, 2, and 20. If I want to take this list and sort it in place, which means it's actually going to change the list, and afterwards it's going to be forever different, I can say that variable name dot sort. I can say, hey, run the sort method on this list. And then afterwards, it'll be sorted. Now, you can do things with sort that allows you to sort in descending order or sort on complex values or anything like that. But if you just call it without any arguments, right here, just the empty parentheses, it's going to look at them and it's going to do what's called the natural sort, which is it's going to look at 1 and 10 and it's going to be like, well, those are correctly, set up. It's going to run like a sort algorithm on it. And then it'll look at 10 and 2 and it'll be like, oh, 10 and 2, I need to swap those around. And then it'll be like 10 and 20. So anyway, it figures out how to sort them inside. This here is the output after we call sort 1, 2, 10, 20, which makes sense because that's the things in order. So sorting changes the list with the dot sort method. That's really important. I'm going to say it again because it's so important. Dot sort changes the list. You don't get a new list out of it. It changes the list. So in the textbook, there's more things that you can do like dot reverse and all that other stuff. I'm going to do a couple of here because these are kind of important. So we can do dot index to be able to find the index of a value. So I want the index of the value 10 inside my list. So it goes along. It's like 0, 1. Oh, I found it. There's 10. And so L.index returns 1. So because L.index, I'm asking what's the index of the value 10? So it returns 1. L.index 40, it goes up here to the list and is like, are you 40? No. Are you 40? No. Are you 40? No. Are you 40? No. Oh, no. And then it throws an exception. So every time you do like dot index or something like that, like this right here, dot index, you're going to want to put it in a try catch block because remember, so every time you do one of these, you're going to want to put it in a try except block so that you can capture that value error and know that it's not in the list. There's another way to do that. I'm going to skip here to the end of the slide. You can say to in list. If you just care about whether or not it's in the list, you can use the in operator. And what it will do is it will search for this value in the list and then return a Boolean value, true or false. If you don't actually need to know what index it's at, you just want to know if it's in there, you can use the in operator. And that is something that we do use quite a bit. And then finally, we saw how to append things to the end of the list. Sometimes you want to insert things at some specific place. So what this does, the original list is 1, 10, 2, and 20. And we're going to insert the value 12 at index 1. So at index 1, right here, remember 0, 1, 2, 3. It's going to take 12 and it's going to be like, I'm going to put 12 inside here and take all of these values and shift them right. So after inserting 12 at 1, we have 1, the newly valued, or the new value that was inserted at index 1, and then 10, 2, and 20, which got like moved over in the list. So remember, lists are sequences. They keep order. So when I put this 12 in here, everything after it is still in the same order. It's just at a new index. A very powerful feature of Python is known as slicing lists. And that's a way to get a part of a list or something like that. So let's take a look at slicing lists. This is one of the things that Python naturally does that is like I said, really powerful. So let's say I have a list like this, 1, 2, 3, 4, 20, 21, and 22. For some reason, whenever I type a list, it's just like, it's always in order. It's harder for me to like write a list that's not in order. So how can we get a part of this list? Let's just say I want like these middle 3, for example, or I want every other element in a list. So I want 1, 3, 20, 22, or I want every other element inside this part. So just 3 and 20. How can I do that easily? I mean, I can figure out how to do it with for loops and all that other crap, but the idea here is I want Python to give me a way to do this easily, to be able to get part of a list or to jump around, like take steps through a list. I want Python to be nice to me and make that easy. Luckily, it is. So our solution in Python is slices. That's when we use the square brackets with at least one colon in them. That's how we do a slice. So slices work by looking at the first number and the last number, 3 and 6. And then it goes to 3, it goes to the index 3 and the index 6, and it gets all of the values up to, but not including that last index. So the slice from 3 to 6 is the values 4, 20, and 21 because it starts at 3 and it gets all the values up to, but not including that last value. So we end up with 4, 20, and 21. When we don't provide a value on one of the sides of the colon, if we don't provide it on the left, it puts a 0 in here by default. So we've got, in this case, we want the values from 0 up through, but not including 6. So that's 0, 1, 2, 3, 4, 5, but not 6. So that's the list that we get out. And these are creating new lists. It doesn't change the original list. It's like, I'm going to pull those out into a new list for you. When we don't put the value at the end here, it puts the length of the list in there. This is a list of how many elements? Well, we can look at that last one here and add 1 to it, and that's equal to 7. So we know there's 7 elements in here. 1, 2, 3, 4, 5, 6, 7. Because remember, indexes start at 0. The last index is always 1 less than the length of the list. So if we add 1 to that last element, there's 7. We know there's 7 in there. So it's going to put the number 7 in here. And it says, okay, I'm going to start at 6 right here, and I'm going to go up to, but not include that 7th one. So I just get a list with 1 element in it, the number 22. And then finally, we can include 2 colons. So here I have 0 here. So I want to go from 0 to 6. Okay, so that means I'm going to start at 0, and I'm going to go up to, but not including 6. I start here, and this third value means I want to jump 2. So I'm going to start at 1, and then I'm going to jump 2. And then it'll get this one. Then I'm going to jump 2 and get this one. Then I'm going to jump 2, and I hit the wall. Boom! And I'm done. So when I say I want from 0 to 6, every second element, I get 1, 3, 20, and that's the new list that's created for me. So in general, those values are start, colon, end, but not including that end, okay? So it doesn't include this end, not including that end, and then the jump or the step. How many do I want to skip? Like I want to go to the second, I want every second element, or I want every third element, or every 10th element. So that's what it looks like in full. Up here, with these original ones, 3, 6, there's no extra thing there. If I can do colon 1, and that would be the same, right? Because I say I want every element in the list. Don't skip any. I want every one element in the list. So that starts at 1 and then goes 2 and 3, et cetera, et cetera. So start, end, not including the end, step. That's how we make slices of lists in Python, which I cannot stress enough, creates a new list and puts those elements into the list for us. Here's something that I don't think is in the textbook, but is you'll see every now and then. So what you can do is you say, I want to slice 3 through 6. So let's look at that. 0, 1, 2, 3, 4, 5, 6. So start at 3 right here and go up to, but not including 6, right there. And it says, I want to replace that whole slice with this list here. Boom. And so what it does is it rips out 4, 20, and 21 and puts whatever is in this list inside there. So we end up with 1, we end up with 2, we end up with 3, and then this whole slice here was replaced by the elements in this list. There's only 1, so it's 100, and then we have 22 at the end. So you can assign to a slice. And you'll see like old-time Python programmers doing this a lot. Sometimes you have a list and you want a copy of it because you want the original copy hanging around, but then you want to create a copy of it so that you can do something with it, like change it and stuff, but you still have the original values in the original order. Like I want to have an unsorted list, and then I want to be able to sort a copy of it so that I know what the values are in order, but I still want to have the original ones around. So there's lots of ways to do copying. In this one here, we're using a slice without any values, which remember, Python will put those values in for us. So it will put the 0 in here because when you don't specify the first one, it's like 0. It'll put in 5 here because when you don't specify it, it'll put in the length of the list, and then it'll put in every one at the end because that's what they want. So this creates a new list that has all of the original values in it. Another way that we can create lists is by taking an empty list and adding that list to it. So what does that look like? I mean, it's an empty list, so there's nothing in there, but the original list has all those values. So when we add two lists together, we get a new list. So this ends up being a copy of the original list because we're not really adding anything to it. It's like adding 0 to a number. We're not adding anything to it. That's called the additive identity of lists is the empty list, which means if you add another list to the empty list, you get a copy of the original list. And then finally, we can just like declare an empty list and then loop over the original list and append those in order. So we build that list up using this loop mechanism. So it'll go through and it'll be like, here's number 4, I'll put that in the copy. Then here's number 20, I'll put that in the copy. Then here's 20. So we can do that too. There's almost never any reason to do it this way. And you probably shouldn't do it this way. This is the fastest, funnest way to copy a list. So if you need a copy of a list, just use a slice with no indexes specified. Something that blows people's minds when they first encounter it is this idea of lists of lists. I can put a list inside a list. What? That's just crazy. But if you think about it, let's say that we had, earlier we had a list of trees and we had a list of flowers. So I could be like, here's a list of trees, and that's got elm and oak. And then I have a list of flowers, and inside that I had just the poppy flower. This is a list of lists. Look at it. There's an outside list which has all of the crap, the big categories, and then inside that I've got sublists like this. And those sublists allow me to provide more details and things like that. So this is what a list of lists looks like if I were to write one out. It's not what they look like in Python. Let's take a look and see what they look like in Python. Let's say I wanted to pair everybody up in the class. I could go through and create a list of lists because each item, each element in this list is a set. These are partners, right? These are a pair of people inside the list. So I've got two sets of partners. And then this outside list is the list of all partners. So this is a list of lists. Let's take a look and see what it looks like here, because you'll often see it written this way in Python code. And so when you see an angle bracket and another angle, when you see a square bracket and another square bracket like this, and then a whole list, like rows of more lists inside there, automatically you should be like, this is a list of lists. Boom. List of lists, just like that. And the reason we write it like this is because it's easy for humans to read. We look at that and we're like, oh, okay, Noor and Asa are a set of partners. Carl and Zubair are a set of partners. So this is a list of partners. When we want to loop over a list of lists, we need to use a nested for loop. Look at that. There's two for loops. This one is inside this. This one here is inside this loop here. So we kind of have to start wrapping our minds around this. So this outside loop for pair and partners, the first value for pairs is going to be this list here. So that list, Noor Asa, is going to be assigned to pairs. And then inside that loop, Now we have pairs, and that's going to be Noor and Asa. It's a list. We can loop over each name inside those pairs, and that would first be Noor, and then Asa, and then we run out of the values in our pairs. And so once we run out of the values in our pairs, we go back up to that loop, and the loop's like, okay, what's the next item in the list? And the next item in partners is now this list here, Carl and Super. So that's the value that's inside pairs. So pairs is now this list right here, Carl and Super. So now we're going to loop over each name in that. The first one is Carl. So that's what will print out next. And then this name and the pairs are going to be like Zubair. That's the next one. And then we've run out of the lists we've run out of names inside those pairs. So once we're done with that, this loop ends again. And then we go back to that parent loop. And the parent loop is like, okay, let's look in partners. What's the next pair? We've already done this one. We've already done this one. Now it's looking for the next one. It's like, oh, I'm done. There's nothing else left. And so finally it exits and goes on to the next one. Getting your mind wrapped around like nested loops like this might take a minute. So don't worry if it doesn't immediately click. I'm sure that there are homework problems for us to try in the book for us to be able to like practice this. So let's say I want to get to the name Carl inside here. Let's say I want to figure out what the first element is in the second list of partners. Okay. So let's take a look at the way that we would figure this out. Partners is a list, and its indexes are 0, which points to this list, and 1, which points to this list. So partners 1, when I type partners 1, that returns the list that has Carl and Zubair in it. I'm just going to type Z. So once I have partners 1, this thing here, now I want this first element right here, which is the 0 index. So I would add another 0 onto there just to get Carl out. So that's what I've got here. Partners 1, which gets me the second list inside this lists of lists, and then the 0th element of the list I'm actually looking at right here, 0, 1. This, again, might take a minute for you to figure it out. The next example might be even more clarifying for you. So think about a tic-tac-toe board. I don't know if you've ever played tic-tac-toe or drafts and knots, as it's called elsewhere in the world. A tic-tac-toe board is a series of rows and a series of columns like this. And so if we apply indexes to them, 0, 1, 2, and 0, 1, 2, our rows are the first index and our columns are the second index. And this board right here would be X, X, O, O. You see that? You see how that lines up between these two things? So what's this one here? This one would be this value right here, that first X. That would be board. And then we look at the row, that's 0, row. And then we look at the column. That would be 0, like that. So that would end up giving us X. Let's look at this O right here, for example. So that would be board. What's the row? The row is the 1, index 1, so that's what I'd put there. And then what's the column? That's index 2, so that's what I'd put there. And that would give me that letter O. So a two-dimensional array, a list of lists, is really... It really kind of looks like a tic-tac-toe board. It might have more values or fewer values. It might not just be 3 by 3. It might not have 3 rows and 3 columns. But we can think of it like this table here with rows and columns. And when we want to access a value inside there to either get it out or to set it, because we can set these with equals, just like we can set any items in the list, then we look first at the row index, which row is it in? And then we look at the column index, which column is it in? And so that's really it about lists. In my opinion, lists are pretty easy to understand because we deal with lists all the time. I first got to do this, then I got to do this, then I got to do that. That's a list of to-do items. Those are things I got to do. Like I've got 2 kids. There's the oldest kid and the youngest kid. There are a list of kids. So, lists are all around us. Lists of people in this class, the list of books on my shelf. All of those are lists. We're very used to lists. And so the idea of a list is not, really foreign to us. In this case here, the way that Python does them is with square brackets and then the values inside them. And we can get to those values either using positive indexes or negative indexes. The positive indexes start at 1 and go all the way to the end. And then the negative indexes start at the end with -1 and then go -2 and then -3 backwards. Finding elements in a list, we can use the in operator to test Boolean value. Is this true or false? We can also do .index, but this will raise an error if it doesn't succeed. So that's, that's a thing. Try except blocks for that. Slicing a list is getting a new list from the old list. The first index is where we start, and the second index is where we end, but not including that one. So in this case, our indexes are 0, 1, 2, 3, 4. We start at index 1, and we go up to, but not including 3. So this is the value that would come out of that slice, and that's what we see. To copy a list, we just slice it without any arguments, and it'll put in the arguments for us, 0 and the length of the list. And then there's a whole bunch of useful functions. There's the length function to give us how many elements are in it, the sort function, the insert, and the reverse. So that's really it. Welcome to lists. Finally, Python's favorite data structure.